Hello Legacy Sabers, Marsh here. So today guys we're going to talk about ellipses, or as you've probably heard them called, in oval. We're going to talk about how to graph them, what does the equation of them look like, something like that. What you're going to want to have notes, writing utensils. You might want to have like multiple colors to kind of draw and color certain things on the ellipse just so you can kind of match things with color. And then you're going to want a calculator just to do some simple square roots today. Parts of an ellipse. And you're saying, well, Marsh, it's just an oval. How much parts can it have? Actually, you'd be surprised. It has quite a bit. One part we're going to talk about, the ellipse, has a center, just like our circles had centers. Our ellipse also does have a center. Along that center, we have what's known as a major axis. A major axis is basically the long point of the oval. Now, the major axis can be up and down, or it can be left and right, depending on how your oval is created or your ellipse is created. The major axis is in the direction of the longest part of the ellipse. On the other end of that, we have what's known as the minor axis. The minor axis is the shorter side or shortest part of the ellipse. Also, what we have located inside of our ellipse is known as the foci. The foci have a distance from the center on both sides. They also have a distance from the vertices, and the vertices are both sides of the major axis. Notice how, guys, the center has a distance from the vertices on both sides, and so does that. You also have the foci and the vertices are going to be located always along your major axis, never your minor. But along the minor axis on both sides, you have what's known as your co-vertices. And to remind yourself, how are you going to remember this? Well, co-vertices, I like to think of them as like the co-pilot. They're the second part of the vertices, so they're the second one. They're smaller, something along those lines. That way you can remember which one is the minor axis and which one's the major. There is an equation for the ellipse that you can use. It's to figure out the distance between your foci and your co-vertices and your vertices. It's derived using the definition, the distance formula, your equation of the ellipse. X squared divided by a squared plus y squared divided by b squared equals 1. That does look very similar to the equation of a circle. Now, here's the thing. A always has to be bigger than B, and B is always greater than 0, so you're never going to get negatives underneath there. There is an equation, however, that relates A, B, and what is considered C. And yes, it looks very similar to Pythagorean theorem, but it's not, because there's a negative there. So A squared minus B squared equals C squared. Here's how I like to remember it. It's a negative in the middle of the A and the B, because there's a plus there. So it's kind of opposite of it. Now, A, B, and C are related on our ellipse. This is where those multiple colors might be coming into play for you. A is the distance from the center to the vertices. So A is the distance from the center to the vertices, no matter if that's 5, 15, 5 square roots of 3. It's as far as they are. B is the distance from the center to the co-vertices. So B is after, is the second. That's why co is the second as well. And then C, notice how C is not located in the equation of an ellipse. So most of the time we're going to have to use this formula to find our C. C is the distance from the center to the foci or the focus. Foci is two focuses. Now, you're probably saying, Marsh, how are we going to memorize this? Well, let's make a little note here off to the side. So A is center to vertex on both sides. B is center to co-vertex on both sides. And C is center to focus on both sides. So I don't know how you're going to be able to memorize these, but after the 5th time of graphing, these kind of come back to you and kind of memorize which one's which. A, first letter in the alphabet, goes to vertex, B is the co-vertex, and then C just has to be the focus. So, to determine if your ellipse has a horizontal or a vertical major axis. So, basically, is it going to be an up and down ellipse or a left and right ellipse? You're going to see which of the variables has a larger denominator. If my equation would be x squared over a squared, because remember, a is bigger than b, I would have a horizontal major axis. Notice x squared would have a larger denominator, so that tells me my x has to be bigger. If a is under my y, that would tell me I have a vertical major axis. Notice if a is under the y, so that would mean my up and down is bigger. Now you're probably saying, I need to see some examples. I agree wholeheartedly. Let's take a look at a couple of examples here. So find the vertices, co-vertices, and foci, and graph the ellipse. So I have the equation x squared over 9 plus y squared over 4 equals 1. Now, first question we need to answer, is it a horizontal or a vertical major axis? Well, I look and see who has the larger denominator. Well, x has the larger denominator, right? So that tells me that I'm going to have a larger distance in the x direction, which tells me I have to have a horizontal major axis. Follow me so far? Now, remember guys, a is the bigger number, and a was the distance from the center to the vertices. And on today, all your centers are going to be 0, 0. We haven't moved it yet. So I know that a has to be 3, because remember the equation of our ellipse is a squared down here. So my a has to be 3, which tells me that the distance from our center, 0, 0, to our vertices is 3 away. So if my center is at 0, I have to go 3 this way, because I have a horizontal major axis, right? And horizontal means I go left and right. And then negative 3. So these are my vertices. I'm going to make little notes that those are my vertices as well. So my vertices are located at 3, 0 and negative 3, 0. My co-vertices. Now my co-vertices were located with my b value. And my b value is the other denominator. But this is b squared. So technically it's going to be b equals 2, because it's the square root of b squared. So that tells me that my co-vertices are located 2 away from my center in both sides along my minor axis, which is basically not my major. So I'm going to have to go up and down both sides. So my co-vertices are located at 2, 0 and negative 2, 0. Now I've pretty much been able to graph my ellipse now. I actually have my ellipse drawn out. Let's find our foci now, which I need to use that really cool formula. A squared minus b squared equals c squared. So my a, we found our a to be 3, so 3 squared minus my b, which is 2 squared, equals c squared. So 9 minus 4 equals c squared, 5 equals c squared. So that tells me c is equal to the square root of 5. Awesome. And the square root of 5 is very close to the number 2.24 roughly. So that tells me my c value is the center to the foci. So 2.24, so my focus has to be right here and like right here. So my two ordered pairs of my focus would be the negative square root of 5, 0 and the square root of 5, 0. Those would be my foci. Let's take a look at another example here. So I got vertices, co-vertices, and foci. Let's figure out first, not on here, but are we a major axis? Is it horizontal or is it vertical? Well, I look here and my y squared has a bigger denominator. So that tells me I am going to be a vertical ellipse. I know I'm going to be going up and down. So my a value, since it's the bigger one, my a value has to be 8 because it's the square root of 64. So since my center is at 0, 0, my vertices have to be 8 away. And since this is a vertical ellipse, since this is with y squared, I'm going to go up and down 8. So 8 there, negative 8 there. So that tells me my vertices are located at 8. Ooh, that's not the right equation. 0, 8 and 0, negative 8, because they are on the y-axis, right? Don't be silly, Marsh. Don't put them wrong. Okay, covertices. That's going to be my B value, because remember, covertices were, I found those using my B value. So my B value is 5, because it's the square root of 25. So that tells me from the center, I have to go out 5 both ways. So out 5 there, out 5 here. Okay, my covertices then are located at negative 5, 0, and 5, 0. Oop, my pen decided to go weird. So I have my ellipse. I can draw him in now. There we go. Now let's find our foci using that equation that we know. A squared minus b squared equals c squared. Well, my a is 8, so this would be 8 squared, minus b, 5 squared, equals c squared. So 64 minus 25 equals c squared. That would be 39. Square root both sides, so c equals square root of 39. And the square root of 39 is approximately 6.2, roughly. So if I go, and I know my foci have to be located along my major axis, which is a vertical one. So I know actually that it has to be right here, right about. That would be one of my foci. My other one would be about right here, because it has to be on the same side as my vertices. Your foci and your vertices should be near one another. So my two dots of my foci, my two coordinate points, would be the square root of 39, 0, and the negative square root of 39, 0. Now, what if I just give you information and we try to write the equation of the ellipse? And you're probably saying, no. Actually, it's not too bad. You just got to kind of remember, what do the various information tell you. Well, I have a center of x, or of 0, 0. I have one vertex is at 5, 0. I have another covertex at 0, negative 3. So, if I have a center of 0, 0, I know it's got to look something like this, right? And we're always equal to 1. I need to know, are you A, are you B, which one's A and which one's B on the denominator, right? So let's actually kind of draw this out. If my center is at 0, 0, I have a vertex at 5, 0. Well, that would mean that one vertex is right over here, right? And since vertex is 5 away from the center, I have to go 5 this way. So would you agree with me? My other vertex would be at negative 5, 0. Which tells me that since these are my vertices, I have a horizontal major axis, because these are my vertices are always located along my major, which tells me x, the denominator of the x squared, has to be a larger value. And underneath that would be my a value, how much I'm going out from my center. So this has to be my a value, which is 5. So this would be 5 squared in that denominator, because that's how much I'm having to go out in the x direction. Covertice, I have one at 0, negative 3, which tells me that I also have to go up 3, so one right here, so 0, 3. So this is my b value, which is 3. So underneath my y, this tells me how far in the y direction I gotta go. That would be 3 squared. So my equation of my ellipse is x squared over 25 plus y squared over 9 equals 1. Let's try another one here. So my vertex is at 0, 8. My focus is at 0, 6. We're going to need to do some drawing here. So I got right here, vertex of 0, 8, so I'll be right here. So that tells me that my ellipse has a vertical major axis, since this is my vertex, which tells me as well that my other vertex is located at 0, -8. So, in that regard, since A is the value from our center to our vertex, my A value has to be 8. The other thing I am told is my focus is at 0, 6. So that would be right here's my focus, which also tells me my focus over down here has to be located at 0, -6. Which one was it? That was my focus. B was co-vertice to center. A was vertice to center. C is focus to center. So that tells me my C value is 6, right? Because there'd be 6 units away. I don't know my B value. So if I start writing out my equation of my ellipse here, I know that I have a major axis. My A value, how much I'm going in the Y direction, is 8 squared. I need the B. I don't know what B is, right? So let's use our formula that we know. I know A squared minus B squared has to equal my C squared. So I got 64 minus B squared equals 36. Looks like I gotta subtract 64. I get negative B squared equals 28, negative 28, aka B squared equals 28, right? Divided by negative 1. Square root both sides. I get B is, break that down, 2 square root of 7. That's what my B value would be, which is close to a value. It's got to be between a little bit more than 5. So about right here. Let's go right there. So this would be what my ellipse looks like. Well, this is underneath here then, that's B squared, right? So if I rewrite my equation of my ellipse, x squared over 2 square root of 7 squared, well, if I follow my direction back, it's before I square rooted, right? So that'd be 28 plus y squared over 64 is equal to 1. That would be the equation of my ellipse. Now, we are going to be spending a couple of days on ellipses, or ellipses, just because it is a harder topic. But that's the end of this video, and I hope to see you tomorrow. See you later, Sabers.